All right. Good evening. This is grade 11, Grade 11, not any other grade. Grade 11. Grade 11. All right. So I hope your day has been good. Grade 11. This is grade 11. This is grade 11. This is grade 11, and more of grade 11. I'm sorry for the delay, guys. I had a bit of a I had to take care of things in the household before I could get some order so that I can be able to settle down and get this lesson in. So I'm sorry, it's an entire 22 minutes after the time that we had agreed. And I'm very sorry about that, but yeah, you know how it is. If only life was a straight line, then it would be great, but sometimes there are curves, there are twists, there are turns. So obviously then that means change of plans and things don't quite go the way that you had intended. So we recalculate and then we re-establish and we try again. Firstly, let us establish if the network is fine, connection is good, there is no glitches in the network, the connection, you can hear me, I'm audible, there's no glitches and the likes. If you guys have those challenges, you let me know, at least if they are being done by me. But if it is you, then you must confess that things are rough on your side, not me. Okay? Not me, but you. No, boy, Tumelo, no, not inequalities. I think you guys are, it's like you are in a hurry. People are in a hurry here. They are in a hurry. And unfortunately, you are with someone who is not in a hurry. Let's first correct the things that we did yesterday, just so that we're on the same page, and then we can move to the next thing. It's not inequalities yet. We are not there yet. We are still on equations. And we will go further, because remember yesterday we introduced quadratic equations for grade 11. Then we looked at 3 methods. We actually spoke about 3 methods. We did not really go in depth into the other 2. We looked at the first method being solving a quadratic equation using the factorization method. This method we've used in grade 9, we've used in grade 10, and in grade 11. We just wanted to make sure that we are all still in the same page. And if you remember, I said this is what we refer to as a quadratic equation. It is in standard form. So if we solve for the x value, which x values are the roots, then obviously our first step is to make sure the quadratic equation in standard form, which it is. Then step number 2, we factorize x squared plus x. If we factorize x squared plus x, I'm sure you guys know that we will take out the variable x because it is the highest common factor. And because it is a variable, we take it out. We don't divide by it. Very important. Then we are left with x plus 1 inside the bracket, which is equal to 0. This is what we call factorizing, the factor stage. After seeing our equation is in standard form, we factorize, because the factorization method can be applied to. We apply the 0 factor law, which basically means that x is equal to 0 or x plus 1 is equal to 0. Then we conclude by stating the roots. So x is equal to 0, or for x plus 1, we transpose the plus 1 to the other side. It becomes x is equal to negative 1. These are our roots for the equation x squared plus x is equal to 0. So those who were here yesterday, hopefully when you did this problem, you also got this beautiful answer. 0 factor law, then the roots. Standard form, factors, the zero factor law can be applied. So we equate x and x plus 1 to 0, then we solve the linear equation. We get the roots, x is equal to 0 and x is equal to -1. Moving right along like a choo-choo train, 3x squared plus 6x minus 9. This equation is also in what? It's already in standard form. If we look at the three terms, can we factorize? Yes. What type of factorization can we apply? There is a highest common factor, but the highest common factor is a number. So that highest common factor number, instead of just taking it out, we do what? Yes, boy Dumelo, we divide each term in the equation by 3. So if we divide each term by 3, the highest common factor, then what we then get is we get x squared plus 3 goes into 6, 2x minus 3 goes into 9, 3 times, equal to 0. This is the simplified standard form, which is great. Factorization can happen smoothly. This is a what? It's a trinomial. So when we have a trinomial and the highest common factor has already been divided by, which is the number highest common factor, because if it's a numerical highest common factor, we divide all the terms by that number. But remember, if it is a variable highest common factor, we take it out. Very important. I think we established this yesterday. So our factors here, obviously x and x on either side. Then the factors of 3, which if we multiply, we get -3, but then if we add those factors, we get +2. Those factors are beautifully and simply what? They are, thank you, +3, excellent, excellent, and -1. Excellent is very excellent. And let's not forget the equal to 0. Then there's a tendency of just leaving the other side and not writing the 0. Please make sure that the 0 is written there. Now we have factorized. The next step is to apply the zero factor law. We take the x plus 3, we equate it to 0, or, please people, it's or, not and. Ne? We take x minus 1, we equate it to 0. This is application of the zero factor law, which I explained yesterday, and then the x values or the roots are x is equal to -3, or x is equal to +1. Smooth and smooth and so good. Okay. Next one, the next homework game challenge example that I left you yesterday was this one. X minus 3 into x minus 2 is equal to 0. Which stage are we in here? We have two factors, we have equal to 0. So what do we do at this stage? We can simply apply the zero factor law. Okay. Tato Makeleni is saying give us a chance to copy that one. The thing is, Tato Makeleni, this was homework, this was a game challenge problem. So I am moving, doing the correction for those people that were here yesterday. Right. So does that mean you were here yesterday but you got this one incorrect? Is that the case? Okay, hopefully the chance that you are looking for you have gotten, and maybe even the previous one you didn't get a chance. Here's the chance. Okay. Right, let's move. This one. Hang on. Okay, so here, thank you, Lonle. X minus 3 into x minus 2 is equal to 0. So here at this point, we have two factors equated to 0. So at this stage, where are we? Do we need to FOIL this one and go back to quadratic standard form? No, guys, we are already way ahead, further along in the steps. So here what we can simply do already is we can actually apply now the zero factor law, because these are already factored and there's a 0 on the other side. So we can apply the zero factor law. So we take x minus 3 is equal to 0, or x minus 2 is equal to 0. Please people, it's or, not and. Difference, or. Then we solve the linear equation. Transpose the minus 3x equal to 3, or transpose the minus 2x is equal to positive 2. These are our roots. Finished. Nothing more, nothing less, not even complicated. It's to the point. You see, very, very important. Yeah. Remember, why is it or? You could take this 3 alone and substitute it into this equation. It will satisfy the entire equation without taking the 2 as well. Okay, that's why we use or. 3 can go in there, it will satisfy the equation alone. Or you can take 2, substitute it there alone, it will satisfy the equation. Okay, yes, you can use both answers at the same time, but we use or specifically to basically denote our answers here. All right. Yeah. And is specifically used when you have to use both to satisfy the equation. You can't use one, So this one is, you can use one or the other. Okay. Okay, anyways, let's move on. Hopefully that was enough time for you to take down. X into x minus 16 is equal to 3 into 24 minus 5x. Okay, so here standard form is so far away from us, we don't have it. So that means we need to actually apply, this is a monomial and this is a binomial, there's a bracket, so we have to apply the distributive law. Alright, this is grade 11. Even this side, this is a monomial 3 by a binomial, so we distribute. Alright, and when we distribute, we multiply, applying the multiplication of the sign, the multiplication of the number, the multiplication of the letter. So here, x times x, x squared. X times minus 16, positive times a negative is negative. 1 times 16, it gives us the 16, and then the x gets nestled close by. All right. Okay. So this is distributive law. Let's remember that FOIL is one thing. Distributive law of a monomial by a binomial is another thing. Okay. So 3 times 24. 3 times 24. Let's see if people have their thinking caps on here. Let me just not do things like that. Yes, after this session, I'm doing a grade 12 class. Thank you, Sokutela. 72. 3 times minus 5x. Thank you, Ska and Tlotlo. Kuhula Nkunika. Amen. Negative, please people, not 15x, negative 15x. Very important, that sign. Positive times a negative is negative. 3 times 5 is 15, and then the x, so it's negative 15x. Now we can see there are 2 terms this side, 2 terms this side. We can transpose the terms. X squared, we transpose them like term wise. Negative 16x will be joined by negative 15. When it transposed, it becomes positive 15x. 72 also gets transposed, it becomes negative 72. What gets left on the other side, as everything is gone, what gets left on the right side? Thank you, Lee. Hey, we have Jet Li in the house. Hey. We've got Chinese characters in the house. My goodness. I saw Li. Uh, Hopefully he's from South Africa, not China. X squared. What's negative 16x plus 15x? Yo, liba chabalala. Yeah, he's chabalaling us here. The negative x minus 72. Now for the factorization, calling upon the powers that be. The powers that be. The factors of negative 72, or the factors of 72, which if we multiply, we get negative 72. If we add, we get the coefficient negative 1. Those factors are, Excellent says it, Precious says it, Queen says it. Who else is saying it? Anyone saying something else that's different? I have a feeling that these people are actually commenting nonsense. Excellent, Precious, Queen. Come on, guys. Someone must give me the actual answer, the true factors. Come on, guys. These people. What are the factors of 72? If we multiply them, we get negative 72. If we add them, we get a coefficient, the negative 1. I'm waiting for someone who will actually give me the actual factors, man. Not this thing that I'm seeing above here. Hey, these people. Come on, guys. Come on. I'm trusting someone who will give me something. Hey, Remo has changed. Remo has introduced something else, negative 9 and negative 8. Okay, guys, remember, I said yesterday that sometimes I'll do this. I want to check if people actually know what they are talking about. Obviously, the people who said negative 9 and 8 are 100% correct. Okay, 100%. Busisiwe, we have not done the other methods. We are still in the factorization method, and for reasons that are known to us. So we haven't gone there, we haven't even touched that method. We are grade 11 learners that are still in the beginnings of our learning. So to them, the other one must relax a little bit. Factors of negative 72, which if we multiply give us negative 72, but if we add they give us negative 1. You guys are spot on. It's negative 9 and positive 8. Right? So you were right. I just wanted to check if the people are really on board. So that was standard form. We have factors now. Okay. Then we apply now the 0 what? Factor law. X minus 9 is equal to 0, or x plus 8 equal to 0. Final answer, x is equal to 9 or x is equal to negative 8. Wow, see my numbers, they are beautiful. Writing nonsense as well. Okay, all right. Hi guys, that was the game challenge, and we are seeing how to use the factorization method. It's very smoothly, very nicely. Okay guys, let's move on to today's session. I'm not moving from this factorization method yet, guys. Like I said, all the people must hang on. We are still in the factorization method. We have not left, and for reasons. So we are still using the factorization method, and for reasons. Okay, yeah. So let's hold our horses. People don't want to hold their horses; they want to run. Hold your horses. Maybe I am slowing you down. If I'm slowing you down, please, people, like I said, remember this is So let's look at, today we'll be looking at solving algebraic fractions using factorization. Algebraic fraction equations. Situations where our equations have fractions, and at a certain point we use the factorization method. Okay. The reason why I am insisting on the factorization method, people, for now, is that I want to check if people can actually what did you do in grade 10? Is the grade 10 stuff still in you, and can you still use it? The grade 8 and the grade 9 and the grade 10 stuff, because this grade 9 and grade 10 stuff was supposed to be foundational. You did it for 2 consecutive years for a reason. Okay, So please just bear with me. So we're going to look at 3 examples today, and then we'll close the class, and then I'll give you your own beautiful, awesome problems to do. Look at this first problem. 1. X is equal to 4 over x. So what do you observe here? X is one term on the left, 4 over x is another on the right. What do we have though? There's a fraction. One of our terms is a fraction. Look at number 2. 2 over x minus 2 is equal to negative 4 over x minus 1 plus 1 over 2 minus x. Once again, we have fractions. You see? 3. 4 over x minus 2 equal to 3x plus 6 over x squared minus x minus 2 plus 4 over x squared plus 4x plus 3. Once again, fractions. So we're going to look at these 3 examples, and I want to then suggest what I will call a recipe for us to use. You know, when you are baking a cake, there's a recipe that you usually follow. The recipe will help you know the steps you need to take. You put 2 tablespoons of this, that thing. You know what I mean, Moss? So let's look at this recipe. The recipe is as follows. The recipe of unpacking or unleashing goodness on a question where the equation has fractions and we need to solve. They suggest that the first step that we need to apply is we need to always do this if we can. You factorize the denominator only if necessary. Step 1, factorize the denominator if what? If necessary. So it means we are looking at the denominator of the fractions, and then we factorize that denominator if it is what? If it is necessary. Now, we should all know by now all the types of factorization that are there. Highest common factor, difference of 2 squares, trinomial factorization, cubic factorization, and all the other types. Grade 11 Presh. Step 2. Find the LCD. Yesterday, find the LCD. What is the LCD, people? Find the LCD. What is this LCD? LCD, what is that? Find the LCD. Do you even know what that is? Oh yes, lowest common denominator. Okay, I see people know. Not lowest common factor, please. The D stands for something starting with the letter D. Factor is something else. We're talking about lowest common. So lowest common denominator comes from lowest common multiple. Multiple. But we say it is the lowest common denominator because the numbers are situated in the denominator of a fraction. So that's why we call it the LCD. Okay, so but in essence it's the lowest common multiple, all right, of those denominators. After finding the LCD, we need to then state something here. This word is state. In other words, you need to give what we call the restriction. Your restrictions. There are restrictions in life. In everything there are restrictions. Things you can and cannot do. Things that you cannot do and you shouldn't do. They are safeguards, those things. Anyways, after finding the LCD, you state the restrictions. 3. You multiply throughout all terms. You multiply throughout all terms by the what? By the LCD. After finding the LCD and stating the restriction. Okay, we'll look at it. Don't worry, Sipuma will go. When we do the specific examples, you're going to see I'm going to actually recap on these steps as I do each problem so that you understand what I mean. Right? After that, you're finding the LCD and stating the restrictions. You multiply throughout all the terms by the what? By the LCD, which is beautiful. Why? Why do we do that? Why? To eliminate the denominator. Why do we multiply throughout all terms by the LCD? To eliminate the denominator. We don't want to have a denominator when we are solving, because we want to get to a place where we have a standard form of that equation. And we know standard form means ax squared plus bx plus c is equal to 0, that form. Then after that we do what? We factorize, because we are still applying the factorization method. We find the zero factor law, we get the roots, and then we go to our restriction and reject any root that is against the restriction. Yay! We find the roots, then we reject any root that is against the restriction. So as I do the problems, I will go back to these recipe steps. Let's go. EG1, x is equal to 4 over x. We look at this, x is equal to 4 over x. Fraction is there. It's 4 over x. So what did we say is step number 1? Step number 1, we factorize the denominator. X, can it be factorized? No, guys. I mean, you remember we said factorize the denominator if what? If necessary. It's not necessary there, so we move on to step number 2. Step number 2 says find the LCD and state the restriction. So what is the lowest common denominator for x over 1? Remember, x can be written as x over 1 and 4 over x. The LCD is x. So we've just written down the LCD. It is x. Then remember, what did we say? We also state the restrictions. In other words, this LCD, which is the lowest common denominator, what value of x can this denominator not be? We know that x as the lowest common denominator cannot be 0. Maybe you're going to ask yourself the question, why can't x be 0? Can someone tell me in the comment section? But why now are we saying x cannot be 0? Why are we restricting our value of x to not being 0 but being any other value? Oh, Lee, undefined. And that is the critical message there, that division by 0 or 0 in the denominator means that our fraction is undefined. And we cannot have a situation like that. So that is why we insist that x cannot be 0. We write that restriction in accordance to our LCD. Once we identify the LCD, we then write our restriction utilizing the LCD. So step number 2 is done. Did we find the LCD? Check. Did we state the restriction? Check. Step number 3. Multiply throughout all terms by the LCD. Let's go back. I saw people saying multiply both sides by x. But do you understand that you multiplying both sides by x comes from the fact that you identified an LCD that is x? That is why you are multiplying by x, because we multiply throughout all terms by the lowest common denominator. Let us go. There's the x that was there equal to 4 over x. So what we do, we multiply this side by x. But we also multiply the other term that we have also by x. This x that we multiply by it in the numerator. So x times x on the left will give me x squared. 4 over x times x will give me what on the right side? This x and this x, they do what? They say goodbye to each other, because x divided by x gives me 1. Then I'm left on the right hand side with 4. We together, mostly. Next step, transpose the x squared minus 4 equated to 0. What is this? This is our standard form. Let's go back, people. Did we find the LCD and state the restriction? Check. Did we multiply throughout all terms by the LCD to eliminate indeed the denominator? Check, we did that. Is the equation now in standard form? Check, it is. We are ready to move on to the next step. What do we need to now find? The factors of x squared minus 4. X squared minus 4 gives us what type of factorization? Precious has told us in the comment section it's difference of two squares. What do we do with difference of two squares factorization? We open two brackets. One bracket will be positive, the other one will be negative. Immediately we do that. The square root of x squared gives us x, which will be the x term that will populate both the first and the second bracket in our first term place. Then the square root of 4 will give us 2, which we will populate both the second term of each bracket. Equated to what? To a beautiful 0. Where are we now? We are in the factor stage. Done. Next step, 0 factor law. Now we can apply the 0 factor law. X plus 2 equal to 0, or x minus 2 equal to 0. Then the roots, which are x is equal to negative 2 or x is equal to 2. Finally, if the roots, any of them, is against the restriction, we reject that root. What was the restriction? The restriction said x cannot be 0. What are our roots? We have negative 2 and 2. Do any of them oppose the restriction? No. So therefore we can embrace both of their roots as our final solutions. Can I get a beautiful, sweet hallelujah, amen? I get it. I receive the message. I receive the message. I receive it. Yeah. Amen. Thank you so much, Sbu. Abu, sorry. Hey, you see, I'm taking Sbani and the Abu, and then I'm forming a new fusion, Sbu, which is not correct. So, thank you, Abu. Thank you, Sbani, Given, Klotlo, Precious, Scar, Pandai Art, excellent. Kumile Liam Wamashutu Ondinako, Joyce, Kohola, Pretty Thug. Man, you got thugs in the house. Yeah. Don't rob me, please. Don't rob me or take out a knife in the midst of the live session. Please, Pretty Thug. Okay, number 2. I hope, guys, we went through, we can see the develop. You see the recipe, it works. I saw some people in the comment section say to me, in this step, say of x squared is equal to 4. Thank you, Nangi. Rose, it smells so good. X squared is equal to 4. I saw someone say, take the square root on both sides. No, people, you are correct. Remember that you can. At this stage, some people will say, take the square root on both sides. Yes, you can. But something to always remember. That's why I'm saying the recipe is standard form factor, 0 factor, or low roots. I mean, I love the fact that we are getting in this Njumayelo, or this beautiful preaching of standard form factor, 0 factor, law, roots. Okay. So like I said, we can actually do that. Take x squared is equal to 4. Take the square root on both sides. But something we need to remember is that immediately when you take the square root on both sides, please don't forget plus minus. Right? Because remember, this is kind of like that rational exponent. Okay, someone else could have said x squared is equal to 4. You will remember, guys, what we said when we were talking about rational exponents, and we said if the rational exponent has a numerator that is even and there's a number on the other side, you can take, someone else could have said, I'll take the reciprocal of half. And then what I do on the left, I do on the right side. That's fine. But remember, it should be positive plus minus. So there's various methods. One person could have used standard form. One person could have used taking the square root on both sides and making sure there's plus minus. One person could have used rational exponent equation approach. All of these will all lead us to the very same what? Answer. Excellent is also talking about cross multiplication. That's perfectly fine. Just remember, people, there's crucial things though, for instance, that are essential for you to actually state. Like the restriction is something that people usually omit to write. You cross multiply, they forget about the restriction, they get two answers, and those answers actually, or one of them goes against the restriction. So if you don't write down the restriction, you lose marks because you did not reject the answer that's going against the restriction. So I am suggesting the recipe to you because the recipe, it takes care of all loopholes that we can anticipate in our calculation. You know? Yeah. Does that make sense, guys? I'm trying for us to avoid losing unnecessary marks. We want all the marks, you know. This guy, that is me, has had the privilege of going to the marking centers and marking papers for matric final end of year exams. And when we are marking grade 12 papers, we notice or we see that people, they lose unnecessary marks because they do not factor in certain important vital steps that are mark worthy. So let us adopt humility. I'm trying to assist you guys. You may think that maybe you came into this live session whenever you decided to first come into it. You came here, it was by mistake, coincidence. Things happen for a reason. You are here for a reason. Some of you I know are very good at maths, very good. You don't even need me, but it helps to fine tune what you are doing so that it is pleasing, to those that will actually be your gatekeepers, that will mark your papers one day. Yeah, Let's move on to the next one, so that we can appreciate the recipe that we are basically here developing. So we have okay, let me rewrite this properly because I hate the fact that I'm rubbing off. 2 over x minus 2 is equal to minus 4 over x minus 1 plus 1 over 2 minus x. Let us start. Let us get the show on the road. What did we say? Step 1. We factorize the denominator if what? If necessary. Step number 1. Now we are looking at the 3 terms we have. We have 2 over x minus 2 fraction, minus 4 over x minus 1 fraction, and 1 over 2 minus x. Grade 11 ln. X minus 2, x minus 1, 2 minus x. Factorize if necessary. This denominator, no need for factorization. This denominator, no need for factorization. This denominator, hey, the order up, it's not giving this order. So that means we need to apply a very important concept we learned in grade 10 and in grade 9, which we call, in order to change the order and then have a x variable first and a numerical value follow, we apply a rule called the, Boitumelo said it as the sign change rule. Beautiful, Boitumelo. So let's do it, the sign change rule stuff. I'm sure by now you guys are experts in the sign change rule. All we simply do, we rewrite this fraction as x minus 2 in the denominator. Then this sign that is positive, we are going to change it to become negative. This is what we call the sign change rule. Think about it. Let's be practical. If you have 2 minus x and all of a sudden you change the order and you write x minus 2, what would help you to actually retain the integrity of that change of x minus 2? It's if you take out a negative sign. Now, this negative sign, look at this. If I take the negative sign and I distribute it back to the x, what happens? What's negative times x? I get back the negative x. What's negative times negative 2? I get back the positive 2. So taking out a negative sign helps me accommodate and retain the identity of the expression. So 2 minus x, if I changed it up and wrote x minus 2, what am I going to do to the sign that is before the expression? I'm going to change it to the opposite sign. So from positive, the sign becomes negative, and then that allows me to change the order of terms that have a negative sign in between. This only applies when we have a expression that has negative signs in between. If we are interested in changing the order and putting the x term first, then we just change the sign, we change the order, we change the sign, we change the order, and then we proceed from there. That is a type of factorization. The what? The sign change rule. I like what someone else said in grade 10 this morning. This other learner said to me, the sign change rule can be called the SCR. And I was like, yo, that is so phenomenal. Almost made me feel like we are talking about a procedure which is like having a shortened procedure in a medical term. You know, CPR? It's like something like that. SCR, the procedure that we apply when we have an expression. Because see guys, there's x, which is our first term, followed by a constant. X followed by a constant. This denominator, it's a constant followed by the x term. But we are also looking at the x term, it's actually negative, right? So what we do, we apply something called, like I said, the sign change rule. It's a type of factorization. Because remember, the first step says factorize the denominator if necessary. So this denominator can be factorized. We take out the negative sign. That negative sign that is taken out will affect this positive to change to be negative. Then the order of our terms, we write the x first, followed by the 2 second. So we have x minus 2 now. So the order now is appealing, all right? If you look at the denominators now, you have x minus 2, you have x minus 1, you have x minus 2. And there's no denominator that needs factorization anymore. Queen Sokudela said, I am lost, sherm. She even adds the R there. It's like rolling the sherm. So Queen Sokudela, I need to comment there and let me know about what is happening. Where are you lost? We applying this sign change rule. The sign change rule, is that where you are lost? You need to capture me. You need to reply back. And also if there are other entities that have been here since the inception of the live, you can please comment so that we can proceed together in the same heart and spirit, if you know what I mean. Amen, Queen Sokudela. The Queen has spoken. She can now ascend to the throne. All right, let's go, guys. So 2 over x minus 2 is equal to minus 4 over x minus 1 minus 1 over x minus 2. Factorization, done. Next step, find the LCD and state the restrictions. Hey, let's go. X minus 2, x minus 1, and x minus 2. What is our LCD? X minus 2 and x minus 2 are common. When they are common, for LCD, we always go for the common expression that has the highest exponent. But if they are common and they have the same exponent, then it means we take x minus 2 once and we write it as our first LCD. Let's move on. X minus 1 is unique and is not the same as x minus 2 and x minus 2. So since x minus 1 is unique, we always write the unique expression as a product. So it is included in our LCD. We write the unique expression as a product of the common. So x minus 2 and x minus 1 is our LCD. X minus 2 into x minus 1 is our LCD. Are we together? Hey. Then state the restriction. Restriction. Look at the first bracket. What will make, let's just look at x minus, what will make that bracket 0 if x is equal to what? If x in the first bracket is equal to what, will that become 0? If x is equal to 2, thank you so much, Abu, you are, Abu, or let's forget about this first bracket, let's look at the second one. What will make that bracket equal to 0 if x is equal to what? If we look at the second bracket. Queen, thank you so much. Rihumile, Kanseko, everyone, yes. If x is equal to 1. So that means our restrictions are x cannot be 2 and x cannot be 1. Why can x not be 2 and x cannot be 1? Let's go back. Let's say we substitute 2 here. What's 2 minus 2 in this denominator? We'll get 0. I want us 10 in nails on. And he just comments on my nails. Hey, this guy, you are not kind, you. No, I'll get you. You are so beautiful. You are so beautiful. You can see even your name says, you know. So keep that up, my friend. If you substitute 2 here, you get 0. If you substitute 1 here, you get 0. You substitute 2 here, you get 0. So really and truly, x cannot be 2 or x cannot be 1. That's our restriction. Are we good, people? Can we move? We found the LCD. We stated our restriction. So the LCD actually helps us in stating the restrictions. Let's move. Step number 2. What does step number 2 say? Multiply all terms by the LCD. Why? To eliminate the denominator. People. Remember, if we are going to multiply, let's say, this first fraction by the LCD. Remember, what is the LCD? We have x minus 2 and x minus 1. Now, I am not going to write that multiplication. I'm simply going to reveal what comes out of multiplying by the LCD for the first term. Let's look at just the first term alone. Remember, when we multiply by x minus 2 and x minus 1 in brackets, we are actually multiplying by these as if they are in the numerator. So it's like x minus 2 is here times x minus 1 times this 2 over x minus 2. So if x minus 2 is at the top and there's another x minus 2 at the bottom and the relationship is just multiply and divide, the x minus 2 and the x minus 2, they do what? They cancel each other. Who gets left behind in the numerator with 2? Which bracket gets left behind with 2 in the numerator? I repeat, if x minus 2 is at the top, okay, maybe I'm going to have to write it because some people are going to be like, so I'm just going to write it in brackets. Let's say we have x minus 2 into x minus 1. We are multiplying each term by the LCD. What happens? X minus 2 says goodbye to this x minus 2. What gets left in the denominator is 1, and what gets left there in the place of that x minus 2 is also 1. Okay, so far we are good, ne? Then, what gets left behind in the numerator? X minus 1 times the 2. So this is what we do. We write what's left behind. 2 into x minus 1. Okay, so we are writing what is left behind. Remember, what did we say? Why do we multiply throughout all terms by the LCD? Why? To eliminate the denominator. That's the purpose of multiplying by the LCD. Okay, so what gets left behind? 2. Why do I write 2 first? Because it is the monomial. Multiplication is commutative. Doesn't matter what I start. If you said x minus 1 times 2, it would just make sense to just make sure that the monomial is before the binomial bracket, so that you know in the next step you'll be distributing and multiplying out and doing all sorts of other things. Does that make sense, people? Take the same LCD. Now this time we are going to multiply that LCD with minus 4 over x minus 1. It is the next term. So imagine you have x minus 2 here and x minus 1. What happens? Who gets cancelled? Who gets left behind? Hey, some people in life get cancelled. Some people get left behind. Maybe even some of you cancelled some friends from last year. Now they are left behind. Some friends are left behind. You are going to continue with them this year because it's a critical year. Some friends won't help you with nothing. So x minus 1 has to get cancelled. He won't help us in the solution. Who gets left behind? Who gets left behind? Negative 4 into x minus 2. Hey, he gets left behind. Yeah, well, some friends are strong. Okay, don't forget the negative 4. Okay, monomial by the binomial. Let's move to the last one. Same thing. We multiply by x minus 2 into x minus 1. Hey, guys, you know what the danger is? You know what the danger is? The danger is sometimes not being able to identify the LCD fully because you are going to multiply by the wrong things. Hey, so we must know how to identify the LCD fully. Please, people, that's where the danger is. So the x minus 2 and the x minus 2, they do the same thing. They cancel out. Who gets left behind? Who gets left behind? Who gets left behind? Yes. Please don't forget the negative 1. Please don't write just pause 1. It's negative 1 into x minus 1. Guys, do you see this beautiful thing that we have here? Now we are back to winning ways. Now we are back to winning ways. What we want to go and aim for now is to get this equation to a form so that we can simplify and be able to get to the answer. You see this thing? I hope you guys are feeling this thing. You are feeling this thing. You are feeling this thing. Sorry guys, sorry for a sec. I need to just attend to something very quickly. There's just something I omitted to do in this problem. When I wrote it out incorrectly because there's supposed to be an x here. There's supposed to be an x there. So even in the initial question, there was supposed to be an x there. I was wondering what it is that is not popping here. So this 2 is supposed to be 2x. Ne? Doesn't really change the question much. It just changes the fact that this is supposed to be 2x instead of just 2. So please accommodate that change. I'm sorry about that. I'm sorry about not having actually accommodated that in the beginning. Ne? Okay, let's go. Now we can multiply out, expand, and get the equation into standard form. So we have a monomial by a binomial. We know what to do. We distribute 2x times x, 2x squared. 2x times negative 1, negative 2x. Negative 4 times x in the other side is negative 4x, and then negative 4 times negative 2 is positive 8. Negative 1 into x is negative x, and then negative 1 into negative 1 is positive 1. How freely we should flow in using the distributive law. Then we transpose terms onto the right side so that we can establish our standard form. So there's a bit of work that needs to be done here, and we need to be very careful in our multiplication. When we use the distributive law, please consider the sign, the number, and the letter, and how it will affect the term that you get. Please guys, these are basic. Sometimes these are the places where we make silly mistakes and then we end up losing marks unnecessarily. Minus 2x, so you transpose everything now. Minus 4x goes over, you have positive 4x. Let's look for another x. Guys will be Okay, back. Okay, we are back. I could see a pretty thug was gonna just do something to me if I wasn't back with the network. Hopefully the network now is a little bit more kosher. I had to change things up again with my network from one connection to the other. Are we feeling it now? Pretty thug, can you confirm? I'm very scared of you, that if I don't do my things correctly here, you'll take me out. So yeah. But I like the fact that you're not a hectic thug, you're a pretty one. Yeah, so maybe things will be better and not be as hectic as I think as well. Alright, so 2x squared plus 3x, then minus 8 minus 1 gives me a negative 9. And then I have equal to 0. I wanted a situation like this so that we can see if people are able to factorize an advanced trinomial using the factorization methods that they learned in earlier grades. Okay. Remember, the coefficient of x squared is not 1, it is 2x squared. So how do you guys factorize? Okay, someone is asking me, how did I get a 3x? Negative 2, if you transpose the negative 4x, it becomes plus 4x on the other side. Transpose the minus x, it becomes plus x on the other side. So negative 2x plus 4x plus 1x, remember this is 1x, gives me what? 4 plus 1 is 5, 5 minus 2 is 3. Then I keep the variable x the same. So that's how I got positive 3x. Okay. Negative 8 minus 1 is negative 9. Okay, right? So yes, this is how we get the equation. Now the equation is in what? It's in standard form. Are we together, guys? Equation is in standard form. All right. Now you'll remember that when we were doing exponential equations, I did suggest, especially when we get to the K method and we find that we have a coefficient that is more than 1, I did suggest a method that would basically make things easy, right? This is, please, for a grade 11 learner who has not done the quadratic formula yet. Okay, you guys will get to that place, but for now, we haven't done the quadratic formula. So if we haven't done the quadratic formula, then it means we have to actually utilize a factorization method that will assist us to be able to factorize this without having to use the quadratic formula. So I did suggest a method the last time we did exponential equations, and that method involved multiplying the coefficient of x squared, which is a, with c. So that's 2 times negative 9. So that's like a times c gives me 2 times negative 9, which gives me a negative 18. Right? That was the first step. We multiply the coefficient of x squared with the constant term. We get negative 18. Next, we find the factors of negative 18. Okay? These factors of negative 18, they need to, when I add them together, they need to give me the coefficient of x, which is 3. So think about factors of negative 18, which if you add them together, they give you plus 3. That's the only thing you need to think about. Factors of negative 18, which if you add together will give you positive 3. What are those factors of 18, which you can add together, that will give me positive 3? Yes, it's called the AC method, the Mtimkulu guy, the Grootboom, the great tree of all time. So what are those factors, guys? Factors of 18.